In today's problem, we are told that a square with side length of x is inscribed in a right triangle with sides of 3, 4, and 5. And if you're not sure what inscribed means, don't worry about that too much. Basically, it just means we have a square that's sitting inside of a right triangle. And this square has side length x. This square has one vertex lined up with a vertex of the right triangle. Now in the bottom diagram, we have another square, but this time it has side length y. So this one is also inscribed in a right triangle with side lengths 3, 4, and 5. But this time we have one of the sides lines up with the hypotenuse of this right triangle. So given all this information, we need to find out what x over y is equal to. And I'm sorry about this. I wrote y over x for some reason, but we really need to find x over y. Now I've chosen this specific problem because it's going to show us a very important problem-solving skill. When we need to find the ratio x over y, sometimes we can actually get it directly without ever actually finding out what x and y are equal to. So maybe there's a clever way that we can get this ratio x over y right away without ever finding out what x and y actually are. All right, let's see that in action. To get there, we must first do a little bit of work. So let's see if we can find x over y. So I've gone ahead and done a little bit of preparation just to save us some time. So I took the top diagram and we're going to get to work on a new page. So first things first, we can mark a few angles. So because this is a square that we know that we have 4 right angles. So this is a right angle, and then we also have this is a right angle because this is a straight line segment that we have, which we know adds to 180 degrees. Okay. We also have this angle over here that I'm going to mark in blue, and now hopefully you can see a pair of similar triangles. Remember the concept of a small triangle lying within a bigger triangle. This is something that we see come up a lot in similar triangle problems. So the ones I've just traced, triangle BFE is similar to triangle BAC. And this is of course by angle-angle similarity because we have a 90 degrees in both triangles and they share an angle in common, this one. Great. Now we can set up our ratios. We know that BF over FE should be equal to BA over AC. Let's plug in everything that we know. BF is unknown. FE is a side of the square. So remember, because this is a square that we have over here, all 4 side lengths are equal. So FE is equal to x. BA is 4. And AC is 3. From here, we can actually isolate for BF. By multiplying both sides by x, we can also say that BF is equal to 4 over 3 times x. So if BF is equal to 4 over 3 times x, we can actually rewrite the side length AB, because AB is just the combination of these two segments, BF and AF. AF is equal to a side length of the square, which we know is x. BF we found was 4 over 3x. So another way of saying AB is that it is equal to 7 over 3 times x. Let's keep this in mind. So that's something worth noting. Maybe we can come back to it later. Now I'm going to take the second diagram and do something similar. Let's see if we can rewrite AB in terms of y now, because we're working with y. And then if we can write AB in terms of y, we can set that equal to something in terms of x. So by similar logic, this is a right angle because, again, this is a square that we have inscribed, and because we have a straight line segment, this angle is also 90 degrees. Once again, this angle is common to two triangles. Which two triangles? Well, there's this one over here, and then there's also the larger one. So again, the same concept repeated twice, smaller triangles lying within a bigger triangle. So let's make sure we get this vertex order right. Triangle BGF is similar to triangle BCA. By angle, angle. And once again, let's set up our ratios. We know BG over GF should be equal to BC over CA. Plugging in everything we know, BG is unknown. GF is the side of the square, so that's why. BC is 5. And CA is 3. So we can go further from here and say BG is equal to 5 over 3 times a side length of the square, y. Alright, so we were able to find BG. So in order to write AB in terms of y, we're going to need another side length here, AG. So how can we get that? First thing to notice is that this is also a 90 degrees because this is a right triangle we have. And because these two sides are parallel to each other, remember this is a square, so these segments are parallel to each other, and it follows therefore that these two are parallel to each other as well. Remember, we're just extending this straight. That means we also have this angle can be marked with the same blue angle. And now we have two equal angles. This is good news for us because it means we have another pair of similar triangles, and we can find AG. So let's use AGD is similar to triangle ABC, once again by angle, angle similarity. Always remember, you can trace out the triangles if you're struggling to see what I'm talking about. So I'm talking about this smaller triangle sitting within this bigger one. And I want AG, so our ratio will involve AG. I'm going to carry over to another page. So AG over GD should be equal to AB over BC. When I fill in everything that we know, AG is unknown. GD is just the side of the square, so that's y as well. AB is 4 and BC is 5. Similarly, we can isolate for AG, which is what we wanted. we know that it is equal to 4 over 5 times y. This is good news for us. If we have AG in terms of y and BG in terms of y, well then let's combine those two segments to get AB in terms of y. So we know AB is equal to AG plus BG. So just take your expressions that you found before and add them up. I'll leave the simplifying to you, but you'll find this ends up being 37 over 15 times y. Okay, so we know we've written AB in terms of y, and we've also written AB in terms of x. Now AB is the same length in both triangles. Remember, AB, the value for AB is 4 in both triangles. This means we can set them equal to each other. So in other words, setting AB equal to 7 over 3x, which is equivalent to 37 over 15y. And now, here comes the finisher. The cool thing I want to show you is we can find the ratio x over y directly. We don't need to know what x and y are individually. It's just from this equation, just a little bit of rearranging should finish the problem. Let's make sure we do this correctly. When we move everything around, we find x over y should be equal to 37 over 15 times 3 over 7. I trust you can see how that algebra simplifies, but when you do a little bit of simplification, you get a final answer of 37 over 35. So x over y is equal to 37 over 35. Maybe we can put that in at the beginning. So I hope you really enjoyed this one. I thought it was very fun and interesting. This is probably one of my favorite problems that I've shared with you on the channel so far. But hopefully you saw how similar triangles all came together to help us solve this problem. That's all we used. Just similar triangles and then a little bit of clever manipulation techniques to finish the problem off. So I hope you enjoyed this one. I will see you in the next video.